In this video, we'll see some important trigonometric identities. Before that, let's understand what are trigonometric identities. These are nothing but equations which involves trigonometric ratios of an angle. And it will be true for all the values of the angles involved. For example, I have the equation that makes sine squared theta plus cos squared theta equals 1. This is for all the values of theta ranging from 0 and less than equals to 90 degrees. It will be true for all the values of theta. This result, this equation is true. So now suppose I have a right angle triangle formed for myself. This is my right angle triangle. Let's call the vertices involved here as A, B, C. And let's give the names to the sides. Opposite A, let's call it length A, opposites this, okay, let's call this as B, and let's call the hypotenuse as H. Let's call this as theta. Now let's see sine theta in this triangle ABC. So if I refer to the referring angle theta, sine theta is perpendicular upon hypotenuse. So for theta, the perpendicular becomes the opposite side. That's the opposite side. And that's the adjacent side. So the opposite side is called perpendicular. So it's A over H. See its squared value. So it's squared the ratio sine theta. Cos theta is base upon hypotenuse. So for theta, the base is the adjacent side. That's B. And we have the hypotenuse is H. That's cos theta, but we want the squared value. This should be equals to 1. All right. So this becomes A squared plus B squared over H squared value. Since H squared is the denominator on both, so we simply add the numerators. But if we see in triangle ABC, if this is the right angle triangle right at B, so we know through Pythagoras theorem, I have H squared equals A squared value plus B squared value. So my A squared plus B squared can be rewritten as H squared over H squared, which gives us 1. So we proved sine squared theta added to cos squared theta gives us 1. Let's see this proof with some more values of theta. Let's take this time theta as 30 degrees. Let's take the value of theta and put it equals to 30 degrees. That is, let theta equals to 30 degrees. So let's put sine squared 30 degrees plus cos squared 30 degrees. Should be equals to 1. So let's check what is the value of sine 30. At sine 30, the value is half. Since it's squared, so we'll square it out. Cos squared 30 is root 3 by 2 whole squared. So this implies I'm getting 1 by 4 added to 3 by 4, which is 4 over 4, which gives me 1. So again, sine squared 30 plus cos squared 30 gives us 1. So this identity is true for all the values of theta. Sine squared theta plus cos squared theta gives us 1. These relations can also be written as, if I want to replace sine squared in terms of cos squared, we may also write 1 minus cos squared theta. Or we want to use the relation of cos squared theta in terms of sine squared, it may be written as 1 minus sine squared theta. This is our first identity. Let's check the second identity. Our second identity will see 1 plus tan squared theta gives us sec squared theta. Alright, we refer back to our right angle triangle, which is this. I'll put this down here. Alright, so my 1 plus tan squared theta is sec squared theta. 1 tan squared theta, tan is the ratio of perpendicular to base. So for theta, the perpendicular is the opposite side, that's a squared, over base, which is the adjacent side, that is b squared. And sec square is the reciprocal of cos, which is h over base, that is the adjacent side, h, the hypotenuse, over base, which is b squared. So let's get this side. This is b squared plus a squared over b squared. B squared plus a squared, again h squared over b squared, which is equals to the RHS, hence shown 1 plus tan squared theta equals to sec squared theta. So this identity is true for all the values of theta except at 90, because at 90 tan and sec are not defined. So my theta ranges from 0 degrees, it is equals to 0, but strictly less than 90 degrees. So you can put any other value of theta and check it. This relation is true, which is true, and you can do more verification of this result using more values of theta. Let's see the third one, that is 1 plus cot squared theta is equals to cosec squared theta. So my 1 plus cot squared theta, cot is the relation of base over perpendicular. So my base, which is the adjacent side, is B, and the opposite side, which is perpendicular, is A, and we squared this out. Cosec, the reciprocal of sine, which is the ratio of hypotenuse h over the perpendicular, which is A in this case. Squared it out. Let's move on. So this finally becomes a square plus b square over a square, and the other side is h squared over a squared value. Let's see further. A square plus b square, again from the Pythagoras theorem, is the h squared value over a square, which is equals to its RHS. So again, this relation 1 plus cot squared theta is equals to cosec squared theta is true for all the values of theta except at 0. Why? Because cot and cosec is not defined when theta becomes 0. So we say my theta ranges from 0 degrees and less than equals to 90 degrees. That's our third relation. Yes. This is a third identity which is true for all the values of theta except at 0 degrees. That's all in this video. Thank you so much.